And welcome everybody to the Daily Space Weather. Today we're doing something a little bit different. We'll have the cosmology and meteorology segments separate from the Daily Space Weather video. We're looking at an indecisive coronal mass ejection and prominence here in 171 angstroms. It's from the SDO, the Solar Dynamics Observatory. The wavelength is 171 angstroms, part of the ultraviolet light spectrum. And we've got some great more coverage of this as well in some more wavelengths here for you later in the video. Fantastic imagery there from the Solar Dynamics Observatory. And there was a coronal mass ejection on the far side of the sun. We'll get to it. Here's a zoomed out view of the same area. We see 0 sunspots. Possible sunspot there rising in the northeast from which that coronal mass ejection emanated. Next, looking at the view from Lagrangian point 5, stereo A is chasing the Earth, orbitally speaking. And as the Earth orbits in this sort of a fashion, stereo A chases Earth, and Earth chases stereo B at Lagrange point 4. And we saw a very slow-moving coronal mass ejection here, taking its good old time to eject. The event kind of started here at about 9 o'clock Universal Time and is still attempting to reach completion here as the corona tries to reach static equilibrium. A far-side coronal mass ejection. So if you're looking at the LASCO, part of the SOHO spacecraft, which is located at Lagrangian point 1, you may see some ejecta on it. It is not Earth-facing in the slightest. There is still a possibility for Earth-facing coronal mass ejections, as there are filaments down here in the southern hemisphere, especially, mainly right here in the southwest rather. So here's a full disk view in 304 angstroms. We've also got 193 angstroms on the full disk. And we've got to make another smAshomash.org presents the sun video. If you haven't checked that out, youtube.com/smAshomash/playlists. You may find all kinds of content that you're not used to seeing on the channel. Little bit of activity there. And here's the full disk view in 171 angstroms. The indecisive solar prominence and coronal mass ejection. Here's a diagram of the solar system. There's where things should be in a week, God willing. Here's a star chart. If you're up before dawn, you may see the Moon, Jupiter, and Saturn rising ahead of the Sun. Why press the button once when you can press it 18 times to get the same result? Anyway, I've drawn in the ecliptic. It's this yellow line, the path which the sun will take across your sky. If you want to put in your location, check in-the-sky.org. Put in your location. We're located in Lehigh Valley, Pennsylvania. Leave us a comment. Let us know your location. The radio flux, the output of the upper chromosphere and lower corona, it's 2800 megahertz, and it's only at 70. A stagnating solar cycle, cycle 25, taking its good old time. 0 sunspots, which is this red line. It's a 1-year chart. The black line is the radio flux. No solar storms forecasted. No coronal mass ejections headed Earth's way. No coronal hole wind streams headed Earth's way. It's solar minimum conditions. And before we move into seismicity, I would note that regarding earthquakes, Volcano Discovery has a great series of tools. And you can see here these great bar graphs that they've created here. Global seismic activity in 2018, 2019. As bar graphs are one of the best ways to look at this data. Fantastic data there from volcanodiscovery.com. Here is global seismic activity year to date. And we are seeing a bit of a drought here in 7 magnitude quakes once again, something we've seen quite a lot recently. By the way, you can also embed this image on your website. It'll be the most current image. Volcano Discovery encourages you to do so, and maybe we'll do that later at smAsho.com. Let's see what USGS has to say about earthquakes. No major ones, only a few in the 5 magnitude range, such as that 5.1 at Vanuatu. Pretty much a lull in earthquakes here, while we see an uptick in volcanoes. A 5.4 and a 5.1 did happen. I think the 5.4 was the largest of the past 24. Pretty calm on the earthquake front. Also, Volcano Discovery has this great tool here where you can filter by magnitude. There are all the earthquakes. There are only the 3+, there are only the 4+, and there are only the 5+. A very convenient tool there for getting quick data about earthquakes. Shout out to Volcano Discovery. Drop me a line. We'll feature you on the channel. Now, if you weren't aware, Ionosphere has now produced another very tall lava fountaining event. It broke its own record with a 300-meter lava fountain, and now it's broken that record with a 400-plus meter lava fountain. Let's check what else has been erupting, and it's quite a lot of volcanoes here. Some are even new additions to the list. So Ionosphere continuing to erupt and fill its crater valley as it transforms into a shield volcano before our eyes. Suwanosejima, uptick there. It's producing a 9,000-foot ash plume now. Sinabung, the world's deadliest volcano over the past few years. Volcanic ash plume reported to be 15,000 feet of altitude there. Similarly sized volcanic ash plume at Semeru on the Isle of East Java. In the country of Indonesia, it's exploding. A 15,000-foot ash plume. Continuous volcanic emissions from Tokono as it explodes, 8,000-foot ash plume there. And here's a new addition to the list, Auba on Vanuatu, producing gas and steam plumes, aka increased activity. And there is a 2-kilometer danger zone A around summit vents, including danger zone area of flowing creeks, as can be seen in the Ambay Caldera safety map. Volcanic alert level remains at 1, despite that small uptick in activity at Auba on Vanuatu. Fuego in Guatemala is exploding, 16,000-foot ash plume there. Sangay in Ecuador is exploding, 20,000-foot plume there. Revenador also in Ecuador exploding, 15,000-foot ash plume above the caldera at Revenador. Sabancaya exploding. Intermittent puff emissions are enough to produce a 24,000-foot plume of volcanic ash. Nevados de Chilean producing only steam and gases. Another reminder from smAsho.com to not pole vault the caldera. And by the way, today I'm wearing my Do Not Pole Vault the Caldera socks. This public service message brought to you at great personal risk and expense by smAsho.com. Smash staff and I. Next, getting back to some more spaced out data for our spaced out viewers. It's the GOES 16 X-ray flux, part of the sun-facing suite of instruments on the crucial GOES 16. And we saw a B-class solar flare here around the time when I was doing show prep. Peak flux of that solar flare, it was B-class right around 8 o'clock universal time. Minor flaring incident. No proton strikes here. We show it daily to show you that nothing's been going on. And here's the GOES magnetometer over the past 3 days. Fairly smooth GOES magnetometer. And the Earth is solidly in a South Pole oriented current sheet. Here's a visualization of that. Shown in red, the South Pole current sheet oriented to the South Solar Polar Field, as opposed to the green current sheet shown out by stereo B, which is located right here at Lagrangian point 4. That is the North Pole oriented current sheet. No changes coming to that anytime soon. Here's another view of the same data, the line of sight ecliptic plane field plot. And here's the coronal hole line of sight plot. And I would note once again, we see the B field of the sun here, this blue series of lines being pulled down to the south, an indication that cycle 25 is slowly progressing here. And the progression into cycle 24 was much more abrupt than this. Is this even a solar cycle? Leave us a comment. Let us know what you think. So here we're looking at the detected filaments here on the Integrated Space Weather Analysis Center. And we do see filaments down here. They're not consistently really marked on the detected filaments. There are also some up in the north, but mainly this area in the southwest. And there is still some possibility of sort of Earth vicinity coronal mass ejections as a result of those. The KP index has only been at 1 or 0 over the past 48 hours. There's the 3-day chart of global geomagnetism as measured by the planetary K index. KP1 is the current condition. And let's take a look at the real-time solar wind. Pretty uneventful over the past 24 hours here. Real-time solar wind density just over 8 protons per cubic centimeter. Solar wind speed 315 kilometers per second, about as low as she goes. When you see the low 300s, that's about as low as the solar wind gets. We have reported a little bit lower than that in the 200s, but 315 is a low solar wind speed. Here's the low magnetohydrodynamic pressure induced by that low solar wind speed. It's 4 hours of geospace magnetosphere movie courtesy University of Michigan. And we see the majority of the pressure here in the magnetotail region. The portion of the Earth where some solar wind gets reintegrated into the outside the geospace solar wind. You can see that pressure building there in the magnetotail region. That is the portion where pressure increases as protons are pulled back into the solar wind, as opposed to trapped in the geospace. Next, looking at geospace delta B ground magnetic perturbations. Again, 4 hours of data. You're looking at nanotesla now as opposed to nanopascals. Magnetohydrodynamic flux density. And we see a fairly steady 4 hours here. I'll let this play through a second time. Since we are living a geomagnetic excursion, some of our viewers think the poles are going to flip. Other viewers perhaps think the poles are going to stay where they are. Still others believe that the poles are going to snap back to the geographic pole regions. Let us know what you think in the comments. And today's cosmology segment will be completely separate. So we're not going to be streaming at all live to Twitch today, although we do regularly stream live to Twitch. Perhaps consider downloading their mobile app. Twitch.tv/smAsho is our URL. It's a great live streaming platform. The official BitChute page of the Smash News Network, least busted name in news, is bitchute.com/smashamash. Thanks to our subscribers over there. Wherever you're watching, leave us a comment and let us know what your favorite social media is and so on, as we are constantly evolving our operation. Also, thanks to our YouTube subscribers. Please don't forget to press like and subscribe if you are viewing the content on YouTube. Also, press the share button, as the algorithms hate us. Today's cosmology segment is going to be a separate video entirely. It will not be included in today's daily space weather video, so make sure you check out today's cosmology segment. Again, it will be separate today as opposed to integrated into the daily space weather. Continuing on, to look at the Earth environment. So here's a diagram of the Van Allen belts. Feel free to pause the video if you must. Distances are listed here in miles. Now we're moving into the realm of electron flux. Here's the 1-year chart of the electron flux to put the coming data in context. Here's a 3-day chart of the electron flux, and we're in a relatively moderate range here. Nothing exciting to report on here, although we do see chaotic electron belts. We'll get to it in a minute. Those levels of electron flux. And we're looking at density here, electron density, literally like a count of the electrons at the F ionosphere layer. No charging hazards to speak of. Here's the forecast model for those greater than or equal to 2 mega electron volt electrons, expecting a flattened moderate range here over the next 3 days according to NOAA. No argument there. And we see chaotic belts here. So here's the total electron content forecast, and you'll be able to note that at nighttime we see significant electron density over the equatorial regions there. So chaotic belts of electrons. I'll let it play through a second time so you can check that out again. So despite relatively low density, here we see chaotic electron belts, and that's typically what we see at electron flux levels that are a little bit lower than average, especially during coronal hole wind streams, although we don't see that right now. Here's one slice of the atmosphere. It's the F ionosphere layer in vibrational frequency. So this is the atmosphere at about 300 kilometers altitude, folks. And like the anomalous electron flux right now, the total electron content, we're seeing an anomalous ionosphere. Now you can see most of the vibrational frequency is north of the equator. That is what you would expect during northern hemisphere spring and summer. However, we see very concentrated regions here, and we see a rather charged up ionosphere on the nighttime side, consistent with the total electron content that we showed earlier. We like when the data is consistent and makes sense with the other data. It is typically what we see on the channel. Sorry if we've debunked your nonsensical conspiracy theories about whatever you're believing nonsense regarding. Sorry about that. You're welcome for the correct information. Here's the latest image from Australian Government Bureau of Meteorology. It's an old image here, about 6 hours old, from 4:45 Universal Time. And again, that's the F ionosphere layer located at about 300 kilometers. We are going to do a meteorology segment today as well. It will also be separate. So today's daily space weather video is going to be standalone, and we'll do separate videos for meteorology and cosmology. Before we close out the daily space weather, I would welcome all of our viewers to the Neo Renaissance. Please visit our website, check our links, support our channel, whatever way you see fit, as we are producing some cutting-edge stuff here, such as the explanation of the mechanisms behind the solar polar field reversal and hence the sunspot cycles. Look for information about that coming out soon. Don't forget to visit our forum, smashomash.com/forum. You can find a link to that on our homepage, as well as the merch shop. Check out the SmAsho merch shop. We just, like 2 days ago, released a new design entitled Vaccinate This. So perhaps check that out. And again, you can find links at smashomash.com to all of that. So let's do our bonus features for the daily space weather today before we close things out with some more close-up imagery of the indecisive solar prominences that we showed you earlier in the video. Here's the latest imagery from El Teide, the El Teide ground-based solar observatory in El Teide, Spain. And we can see the filaments down here in the southwest are still intact, have not ejected yet. Some filaments in the north also visible up here near where there is a slight prominence. You're looking at hydrogen alpha, 6,562.8 angstroms. Next, I'd like to thank our patrons, a true source of funding for the content. These videos would unlikely exist. Had it not been for our patrons, you would probably not be able to see them. We may still be making them, but they may be all set to private. Sorry about that. Please consider supporting our content at patreon.com/smashomash. Here come the last of your bonus features. The high-resolution colorized magnetogram, freshly refreshed for your refreshingly refreshing viewing pleasure. 0 sunspots on the intensity gram. A couple areas of magnetic organization, here, and one over here, and a bit down here, but they're all just plages. No ombre visible aka no sunspots. So here's a couple more images here. It's this indecisive solar prominence from which a solar flare, actually was a solar flare associated with this, as well as a coronal mass ejection on the far side of the sun. Great view of that. I'll call it indecisive solar prominence. And here's an additional close-up of that region with a great Earth scale as well. Thanks for tuning into the Daily Space Weather, folks. Please remember to share the video on your social media, as again, the algorithms on YouTube for some reason have some sort of beef with us, probably because we're right of Mao Zedong, politically speaking. In any case, remember, stare at the sun. Welcome to the Neo-Renaissance. When you're staring at the sun, don't drink, but if you do, don't drive. And since it'll never be now again, may that solar wind be at